Welcome to this chapter dedicated to mechanical problem solving. Mechanical systems are essential for performing many complex tasks, but their proper functioning depends on rigorous maintenance and the ability to quickly diagnose faults. To ensure safety and performance, it is crucial to understand the risks associated with these systems and adopt a methodical approach to identify and resolve failures. In this chapter, we will cover the essential steps for diagnosing mechanical failures, tools and analysis techniques for identifying the root causes of malfunctions, best practices for effective maintenance and a safe working environment. Our goal is to provide practical methods to minimize downtime, extend equipment lifespan, and ensure operator safety. Ready to dive into the world of mechanical problem solving? Let's go. Mechanical systems pose potential hazards that must be anticipated to ensure safety. Common injuries include crushing, shearing, cuts, entanglements, and impacts, often caused by transmission elements, moving parts, equipment mobility, and load lifting. To minimize these risks, it is crucial to check the condition of machines, wear protective equipment, and follow safety guidelines. Good prevention practices help create a safer and more efficient work environment. Mechanical work also exposes operators to other dangers. Energy-related risks, electricity, hydraulics, and pneumatics can cause severe accidents if mishandled. Environmental risks, noise, extreme temperatures, vibrations, and exposure to pollutants can affect worker health. Human factors. Poor system design, improper equipment use, or lack of training increase the risk of accidents. To prevent these hazards, it is essential to follow proper procedures, use appropriate protective gear, and ensure adequate training. The safety of mechanical work depends on multiple factors. Unfortunately, several issues significantly increase accident risks. Poor machine design can lead to unexpected failures or expose operators to hazards. Using unsuitable equipment for a task increases operational risks. Working on a running machine can result in serious injuries. Unsafe operating procedures raise the chances of accidents, especially when safety protocols are ignored. Lack of operator training reduces their ability to identify and avoid risks. Failure to emphasize safety awareness often results in risky behaviors and poor hazard evaluation. To reduce these risks, it is essential to use well-designed machines, follow operational protocols, and provide ongoing operator training. Safety should be a priority at every stage of work. Mechanical equipment commonly experiences various failures, such as wear and material fatigue, leading to progressive deterioration of parts, lubrication problems, causing excessive friction and accelerating component wear, misalignment and incorrect adjustments, affecting machine operation, transmission failures, such as damaged belts or gears, vibrations and excessive noise, indicating imbalances in equipment, thermal issues caused by overheating or poor heat regulation, leading to component damage, hydraulic and pneumatic failures, such as leaks or pressure losses, electrical failures, disrupting the operation of mechanical systems. Key solution: regular maintenance and close monitoring of equipment condition help prevent these problems. The first step in solving a mechanical issue is accurate problem identification, which involves observing symptoms, pay attention to abnormal noises, excessive vibrations, power loss, or overheating. These provide clues about the malfunction. Analyzing data. Reviewing instrument readings and failure history helps identify trends and anomalies. Considering operational conditions. Understanding whether the issue arises from overloading or improper use. Conducting a physical inspection. Visually examining components, connections, and signs of wear or damage to pinpoint the problem. Once the problem is identified, follow a structured problem-solving approach. Formulate hypotheses. Identify potential failure causes based on symptoms, whether mechanical, electrical, or environmental. Validate hypotheses. Perform tests and measurements to confirm or rule out suspected causes. Implement solutions. Once the root cause is identified, apply the necessary repair or adjustment, whether replacing a part or recalibrating settings. Collect data. Throughout the process, analyze symptoms and evaluate their impact to prevent recurring failures. Post-repair verification. After fixing the issue, test the system to ensure it functions correctly and check for any new problems. This systematic approach ensures accurate and effective mechanical troubleshooting. Root cause analysis is essential for permanent problem resolution. A widely used method is the 5 whys technique, which involves repeatedly asking why to trace the root cause of a malfunction. For example, why isn't the machine working? Because the belt is broken. Why is the belt broken? Because it was too worn. Why was it worn out? Because it wasn't replaced on time. The idea is to keep asking why until you reach the fundamental cause of the issue. Important note: avoid jumping to conclusions too quickly. Observe and analyze the problem thoroughly before determining a solution. As we analyze common generator issues, let's break them down systematically. If the engine won't start, it could be due to a dead battery, poor electrical contact, or insufficient fuel. So we check and charge the battery, inspect the connections, and ensure there's enough fuel. If the generator runs irregularly, misfiring or losing power, the culprit might be a clogged air filter or blocked injectors. So cleaning or replacing the filter and purging the injector should resolve it. Overheating can cause automatic shutdowns, often due to low coolant levels or poor ventilation, requiring us to top up coolant and inspect the cooling fan. If the generator is producing unstable electricity, fluctuating voltage might indicate a faulty voltage regulator or alternator issue, which we diagnose by checking and potentially replacing these components. Lastly, if we see excessive smoke, whether black, blue, or white, it suggests combustion issues or oil leakage into the chamber, meaning we must inspect the fuel injectors and check the engine oil quality and level. By understanding these common failures, we can quickly troubleshoot problems, minimize downtime, and maintain a well-functioning generator. Conclusion: ensuring safety and performance in mechanical systems requires a methodical approach and thorough risk analysis. Quickly identifying failure causes of failure is essential for effective repairs. Using diagnostic tools and case studies helps pinpoint faults accurately, leading to optimized maintenance and reduced costly repairs or downtime. By following these strategies, we ensure optimal equipment performance while minimizing risks and improving operator safety.